Hey guys, welcome to the video version of 0-3 Piecewise Functions. In class we did a Desmos activity, which I haven't done before, so we'll see how that goes. So especially if you didn't understand stuff from that, then this is a good video for you, or if you missed class. First, the warm-up that reviews the stuff that we did in the last couple classes. Having some classes got through this, some classes did not. When we are in this general or graphing form, we have to figure out what our slope and HK is. So in this particular case, on the first one, we have a slope of -2, and we have an HK, or a locator point, of -4.7. This how it is. So back to our warm-up, when we have right here we've got 4 or x plus 4. That means that 4 has to be negative in order to turn that from an x minus h to an x plus, and that can be confusing for a lot of people. So on this one, we can start at the point -4.7, make a point. Our slope is -2, so we're going to go down 2 and over 1, make a point, down 2 over 1, make a point, down 2 over 1, make a point, so on and so forth. I don't have a ruler on me, so this is going to be the best I can do. That's our line. On the second one, we have a slope of 3/4 and an HK of 2, -1, because this is because this is a minus. You don't know where I'm pointing. There we go, because that's a minus. It's just what's in place of h, which is a 2, so that's where that 2 comes from, and then the -1 right there. So then we start at 2, -1, and we go up 3 and over very squiggly 4, and we make our hopefully straight line that would actually, let me undo that. There, let's try that one more time and see if we can do just a tad better, a little bit better. And on the last one, slope is 3, and our HK, our locator point, is the point -1, -9. So hopefully you're starting to see often the H is often what the opposite of what people would expect it to be, and then the K is pretty much what exactly you would expect it to be, whatever the sign is. So -1, -9. We're going to go up 3 and over 1, up 3 over 1, up 3 over 1, so on and so forth. Hopefully use a straight edge to make our line. And then come back. Reviewing this graphing form really fast. A, that's our slope, and HK in the linear version is our locator point, and that is any point on the line when we're looking at a linear equation. Apparently I can't write. So the thing you need to really pay attention to is this right here. That is a minus, and so it's very, very important to recognize that whatever h is often going to be the opposite of what minus. Oops, I don't know why I did that. So that's the review of our graphing, also general form, also point slope form. So there's different names for this, but this is going to be the basis for what we do in Unit 1. Did that in the other video, so I'm going to go over. Okay, so what we are doing today has to do with piecewise equations, or piecewise functions. And a lot of this has to do with knowing how to write your x's and y's. So, or writing your domain for these. So I want to jump forward and talk about some of these places here. So on this, we are looking at a trend that changes. So if I look at one part of it, my line of best fit might look something like this, but right around there, it kind of changes directions. And we have something like this. Those are obviously not the same two things, and it wouldn't make sense to have a line that went through here because the trend changes, so I want to take that off. So what we would do is we would have two different lines. So I would make what's called a piecewise function. My line for, I'm going to call this my equation for line A, and my equation for line B. I'm not finding those equations just at this very moment. And then I also have to put in the domain restriction. So the domain restriction here, I'm going to call this 2. This is for x values from 0 to 2. So 0 is greater than or equal to x, which is greater than or equal to 2. Or sorry, less than or equal to 2. From here on out, I'm looking for x going from, and I have to stop this at 8 because I'm not going above 8 on this particular one. This is an out to infinity. This would be for 2 being less than x being less than or equal to 8. I want you to notice where I have the same number. Whoops, wrong one. Same number here and here. I have to pay attention to these two signs because this one has an or equal to, this one can't have the or equal to because you can't have them occurring in the same spot on your graph. So it can only be in one part. So looking at the actual equations and how we would put this together, I'm going to look at just these two and their individual equations, and then I'm going to put this together in a piecewise function. So this particular one has a y, sorry, you can't see what I'm pointing to again. This particular equation, we have a y-intercept at 0, and we have a slope of 2, up 2 over 1. So this equation is y equals 2x. We can write plus 0 if we want to. The other way to write this is in function notation, f of x equals 2x. So I'm going to put an or there. On the other one, I have a y-intercept of -2, and I have a slope of 1 over 1, or just 1. So y equals 1x minus 2. I can also write that as f of x equals, and I don't actually have to write the 1, but for some that's a good reminder, x minus 2. So I have two different equations here, y equals 2x and y equals x minus 2. So when I move forward, next slide. So if I move forward here, and I'm going to add to this just a little, hang on. I'm going to put a closed circle here and an open circle here. All right, so what I have going on here is from, if I look at this as my boundary point, where the graph changes, this is where x equals 2. So up until x equals 2, from here over, this has the equation of, colors are all screwy, of f of x equals 2x. I forgot my parentheses there. And then at x equals 2, it changes to, if I look at this going back, this is the equation that we had before. This is f of x equals x minus 2. Those are my two equations taking place on the same graph. So what we do is we create a piecewise equation out of this. So we have f of x, a little bracket there, and we have 2x, that's for this one right here, and that I'm going to write my domain restriction like I was doing on the other slides. So that is for x is less than or equal to 2. And I wrote the or equal to because of that right there where I had the closed circle. And then for the second part, for this part right here, that is my x minus 2, so that's my equation, and that's for the domain x is greater than 2. So what I have here is the equation, and then this is called the domain restriction. Squished in there. So that is a piecewise function. These can get much more and review domain. So if we look at domain, first of all, domain is all the possible x values of a function. What's important here is to recognize that we only care about the x values. We don't care about the y values. And so the x values are basically, we're just looking at starting and ending. Sorry, that got a little off there. And what the x values are here and here, because that's really all we care about. So as we go from left over to right, our lowest x value is -3. So if I look at this in terms of the point, so this ending point down here is not -3, -5, sorry, and the y value is -3. So this is my x value, that's all I care about. So this is -5, and this x value over here, because this point is 10, 3, is only the part that I care about is that 10. So x is happening anywhere from here over to here. So my domain for this, x is in the middle here, x is greater than or equal to, because this is a closed circle, -5, and it's also less than, because this is an open circle, 10. Hopefully these are some things that you've seen before, but if they're not, it's pretty important to review. So we'll do a few more of those. So if I write the domain for this one, and I just want to use a different color, here's my x values. That's my lowest x value up to my highest x value without any gaps in the middle. So my x value over here is -6. My x value over here is 8. And x can be anything in between. So x is greater than or equal to -6, again, because that's a closed circle. Closed circle over here as well, so less than or equal to 8. And notice this is continuous. As we start from the left, this is continuous all the way through, no gaps, anything like that we need to concern ourselves with. On this next one, this is a little bit trickier because we have 3 different sections here. We've got one that starts here and here. This x value is -1.5, and this x value is -4, so -4. So this one we have going from -4, x is greater than or equal to -4, and less than or equal to -1.5. That's one part of this domain. And then for the next part, we have -1 and we have 2. So for this section, x is greater than, because this is a open circle, greater than x and less than or equal to 2. And for the last part, I'm going to say this is an arrow over here because I cut it off and I can't tell. So this is starting at 1, nope, just kidding. This is starting at 1.5 and going out to infinity, hence this little arrow that I just added into. So that means that x is greater than 1.5. It's anything from 1.5, not including 1.5 because of that open circle, and above. So this brings us to what's called a piecewise function. I'm going to shrink that down a little and show you how I would write this. Actually, I'm not, because we are doing just linear stuff right now. So this middle part right here will be a little bit tricky, not knowing what we haven't learned yet. So focusing on the domain part anyway, there are 3 different parts to this one. So now I'm going to go back to what I started to do before. I don't think I have a great example because throwing this together kind of last minute. So this one, this equation right here, the first one, has a y-intercept of -4 and a slope of -3. So we're going down 3 over 1. So that equation part is -3x minus 4. The other one has also a slope of -3. This y-intercept is 1, 2, 3, 4, 5. So that one is -3x plus 5. So those are my equations. That's part of it. That's f of x for those 2 equations. And now I have to add the domain restrictions. So for the green one, my lowest x value is -2, and that's a closed circle at -2. So -2 is less than or equal to x, which is less than or equal to my x value here of 0. For the yellow one, I have an x value of 0, and it's less than, because this is an open circle, x, which is less than or equal to, and that looks like an x value about 1.5. So that is my piecewise equation for that one. Look at one more example. Hopefully this video works out okay. I'm going to bring this up here just a little and shrink it down just a little because I can't see it off the side. All right, so I'm going to put these in 3 different colors. So I've got my yellow, green, and blue. So I've got some boundary lines at I'm going to put the boundary lines in red. That kind of tells me, because they cross here, but remember they don't overlap. One's got to be open circle, the other's got to be closed. So what I'm looking at for the yellow, whenever I have a flat horizontal line, that's just, well, I'll start with my f of x first. So f of x, no, I don't need that part. The yellow down here, that is just -2, because y equals -2 on that yellow one. For the green one, I have a y-intercept of 4 and a slope of -1. So that's going to be -1x plus 4. And then for the blue, this is a slope of 1, so just x, and it's got a y-intercept of 0, so I could write plus 0, but I don't have to. What I need to put in next is the domain restrictions. So the first one, the yellow one, closed circle going to the left, which means that my x has to be less than -3. So x is less than -3. The next one goes between -3 and 0. Open circles at both, so I need to have, oh, I'm sorry, I made a mistake on that one. It's a closed circle, so I need to have the or equal to. So hopefully you guys caught that and didn't confuse you too much. So -3 is less than x, which is going to be less than 0. Open circles on both of those, on both ends, so that's why I don't have the line under here. And then finally, the last one, that is just from 0 onto infinity. So I can write that as x is greater than or equal to because that's a closed circle, 0. And that's my piecewise function for that. So that is linear piecewise functions. There's some stuff I skipped through here because it did not lend itself to the video. And hopefully that works out okay for everybody. So have a good day.